All right, this video goes over the Unit 4 study guide. All right, the first part is substitution. For the first one, I took what y is equal to, which is 3x, and plugged it into the equation instead of y. When I solved for x, I got 4. Then I plugged that back into the first equation and got 12. So my point is 4, 12. We're skipping to 3. We're kind of going across here. So these kind of confuse people because you have them both solved for y. So what I did was take what y is in the first one and plug it into the second one. So I have 6x minus 5 equals negative x plus 9. I solved for x and got 2, plugged that back into either one and got 7. So my point is 2, 7. Okay, so it seems like I duplicated number 3 here, so I will work out number 2 for you here. This is number 2. I have negative 2x plus 3y equals 11, and then I have x equals 4y minus 3. So I'm going to take what x is equal to and substitute it in the first one for x. So I have negative 2 times the quantity of 4y minus 3 plus 3y equals 11. So I have negative 8y plus 6 plus 3y equals 11. I'm going to combine those. So I have negative 5y plus 6 equals 11. Subtract 6. So up here I have negative 5y equals 5. Going to divide each side by negative 5. So I have y is negative 1. I'm going to plug that in to the second one. So I have x equals 4 times negative 1 minus 3, which is negative 7. So my point is negative 7, negative 1. If you look at the fourth one, this one's a little tricky because I'm going to take what y is equal to and substitute in for y. Make sure you keep that negative sign and you distribute that negative sign. It's a little thing but easy to forget. So I solve and get 2, plug that back in and get 3. So my point, it's negative 2, positive 3. All right, let's move on to some elimination. The first one is set up nicely so you can eliminate the y's. Then you solve for x and you get 5. You plug 5 in. I just go to the top, doesn't matter which one, and I got y equals 2. So my point is 5, 2. Number 2, all I did was change the sign of the top one. I prefer to add. I guess you could subtract them. It doesn't matter, but I like to change the signs. So I end up with negative 9x equals negative 27. I solve for x, I get 3. Plug that back into the top one and got 4. So my point is 3, 4. All right. Next ones, I had to make some changes. I changed the top one. I multiplied by 2 so I could eliminate the 12s. So I get negative 5y equals 30. Solving for negative 6, y is negative 6. Plug that back in. I got x as negative 1. So my solution is negative 1, negative 6. Number 4, I multiplied the top one by 8 so that I could eliminate the 8y's. So I got negative 28 equals negative 28x equals negative 28. Solving, I got 1 for x. Plug that back into one of the equations, and then I got negative 3. So my point is 1, negative 3. So next leads us to this graphing one. And I made a mistake here graphing the second equation. So when I graph that correctly, you have starting at 3, and I have down 1 over 3. Up 1 over 3, up 1 over 3. So if I graph that correctly, whoa, not the straightest of lines. They are intersecting right here. So my solution is 1, 2, 3, negative 3, 1, 2, 3, 4, negative 3, 4. So that's that one. This next one, you have to put them into slope-intercept form, and they cross at negative 3, 2. The next section has you use whatever way you think best. This really could be elimination if you choose to, but since I had those x's and y's without coefficients, I isolated x, plugged that in to the bottom equation, and I solved for y, which is negative 3, plugged it back in, and it got 8. It would work for elimination too, suited for each. Number 2, I definitely would eliminate here, and you know I don't like to subtract, so I changed the bottom one to positive so I could eliminate the 2's, and I ended up with negative x equals negative 9. Flip the sign over, plugged in that 9 into the other one, so I got 9 and negative 6. All right, let's see what we have next. Okie doke. The school that Danielle goes to is selling tickets to the annual dance competition. On the first day of sales, the school sold 1 adult ticket and 9 child tickets for a total of $117. The school sold 1 adult and 4 child tickets for a total of $57 on the second day. What is the price of each type of ticket? So here's my 2 equations. X plus 9y equals 117. X is adult, y is child. And then I had originally I had x plus 4y equals 55. I changed the signs here. That's why I was a little confused, so I could subtract. So I have 5y equals 60, which gives me $12 for did I flip those? No, $12 for a child tickets, $9 for adults, which is a little confusing. Yes, it seems that the child tickets cost more. Number 2, the state fair is a popular destination for field trips. GMSS needed 7 vans and 12 buses to get 339 students there. Geneva Middle School North needed 13 vans and 7 buses for their 278 students. Every van had the same number of students in it, and all of the buses also had the same number of students. How many students can fit in a van and how many can fit in a bus? So I made X the students in a van and Y the students in a bus. We had to deal with some pretty big numbers here because I chose to eliminate. So these were my 2 original equations. 7x plus 12y equals 339. 13x plus 7y equals 278. I chose to multiply the top by 13 and the bottom by negative 7. Got through my pretty large numbers here, and it ended up that y is 23 students in a bus and x is 9 students in a van. Number 3, this is the sum of 2 number problem. The sum of 2 numbers is 23 and their difference is 5. Here's how you set that up. I isolated x, plugged it back in. So y, I believe, is 9 and x is 14. Sum of 23, difference of 5. At a sale on winter clothing, Cody bought 2 pair of gloves and 4 hats for $43. Tori bought 2 pair of gloves and 2 hats for $30. Find the prices of hats and gloves. So I'm going to make X the prices of gloves and Y the prices of hats. So I have 2x plus 2y equals 30, 2x plus 4y equals 43. I eliminated those 2 x's. So gloves are $6.50. I'm sorry, hats are $6.50 and gloves are $8.50. I think this is the final one. Tickets to a movie cost $7.25 for adults and $5.50 for students. A group of friends purchased 8 tickets for $52.75. Determine the total number of adult and student tickets. Now, this isn't really obvious, this one. It doesn't come right out and say. So here's the price. We have $7.25 for the number of adults, $5.50 for the number of children, and that's $52.75. But it says there are 8 total tickets. This is the one you got to kind of come up with on your own. It's not so obvious. Since the X and Y were by itself, I chose substitution. Be careful with your signs when you do this. So I got 5 adult tickets and 3 student tickets. Okay, here is the first inequality. Make sure you shade the correct side and that your line is dashed. Number 2, your line is dashed. Make sure you're shading the correct sides. 3, line is still dashed. We're shading the left of the line. 4, you had to put that one in slope-intercept form first. So we had 5x plus 4y is greater than 12. I subtracted 5x. I have 4y is greater than negative 5x plus 12 divided by 4. So I have y is greater than negative 5/4 x plus 3. Line is dashed, and you shade to the right. So here, be careful when you divide by a negative number. You had to flip the sign. This is a solid line. Don't forget, when you divide by a negative number, you have to flip the sign. So when I put this into slope-intercept form, I'm going to subtract x from both sides. So I have negative y is greater than or equal to negative x minus 2. I have to divide by negative 1, so I got to flip it. So that's how that one is done. So this one is a horizontal line. You're going to shade underneath where all the values are less than or equal to 5. So it's a solid line. So this key only shades the solution, and by solution I mean the area that is solutions for both of those equations. In this case, it's this area here. Both the lines should be dotted. In this case, this line is dotted, and then this one is solid, and this is your common area right here. You had to put these into slope-intercept form here. This little tiny sliver is your common area for number 9. For number 10, make sure you flip the sign when you divide by a negative. Your little common area is there. If you find something weird, go back and make sure you flipped your sign right there. Last couple, again, this little sliver here is the common. One is solid, one is dashed. And again, make sure you flip the sign right here when you put it into slope-intercept form. If something's weird here, that's probably your mistake. And this shaded area is your common area. Whoops. I think this is the last one. You got this little sliver up here that's common. Just that tiny sliver. And I think that is it.